We have a data set here. To do an ANOVA, you typically go to the general linear model. You can click on Univariate. Normal, it's just in a standard one ANOVA. You're going to have one dependent variable that's continuous, and you're going to have one independent variable, which is a discrete variable. So you can do the general linear model and do this just right here. You can also add in covariates. You can add in multiple fixed factors, and you always want to go through all of these combinations here. So the big one here is the options. So you want to means. You always want to compare main effects, and we have a post hoc test here. The LSD is a good one. There are others to choose from. There's a whole bunch of things you can select. I just have descriptive and homogeneity tests here. So I'm going to kind of do this all together so you can see it. So we did a univariate. So we have our, I hope you can see that. So we have our variables. One thing to keep in mind always is the numbers in these groups can actually affect these. If they're not equal enough, that can create some problems. And it looks like it's our equality of variances test here. But then we have our descriptive statistics. And now we have our test for between subjects effects. So you're going to go down here to we had our baseline systolic blood pressure was our dependent variable. And with ANOVA, you have your sum of squares, your degrees of freedom, and you calculate an F statistic. And then the significance here is 3 zeros, so we know it's certainly less than 0.05, certainly a significant finding here. And that's how you would conduct just a regular, out-of-the-box, regular ANOVA. But we also, if you recall, we factored in some other variables. These are the post hocs. I'm going to kind of go through this. But we also go down here and we have the univariate tests for the whole model. Oh, let me go back. You always want to go back and see what you did. Okay, I see. We had systolic blood pressure change was our dependent, and then the baseline systolic was the covariate. So again, yeah. So here's what I want to show you. Here's what a ANCOVA will do. Do you see here in the descriptive statistics, we have the mean change in blood pressures, and they range, from 1.48 up to 12.24. And this is just looking at the change in systolic pressure. But now in this analysis, we're actually controlling for their baseline systolic blood pressure. I know that may seem complicated, but what we're saying is maybe the people with higher systolic blood pressures, are the ones that really have the big change. So if we put that in as a covariate, and if you notice here, so let's go back to the Mid-Atlantic here. It's 3.4, but earlier here it was 12.24. So what's happening? Well, so the baseline systolic pressure is actually a pretty significant covariate in this model, okay? And it's basically recalculating, it's estimating the marginal means. It's estimating if you're literally controlling for that variable, what would those mean changes have been. And so then when we come down here, we have our ANCOVA test, and so we have we have a significant analysis of covariance. So we know we have a significant covariate. Of course, you have to go back to these pairwise calculations to really figure out where those big differences are going to be. And I would expect to see big differences in the Mid-Atlantic, because that's the one that really had the significant change in the blood pressure. So let me go back here. Go back to the general linear model. And again, so that's, without the covariate, we have our just regular ANOVA. If we want to add a multi-way ANOVA, we can also add, so we have region. We could also, for example, add in gender. We could even add in their blood pressure class. All into these. There's no limit to the number of fixed factors. These are the independent variables. We could probably even add in multiple covariates, and it's going to make this considerably more more tables, more complicated. But you can add multiple variables, so you just have a much larger. And you can see here when you do our between subjects, it's looking at all of these factors. And so the region actually is not significant, but many of these others, and then it's doing the multiples. Region and gender, not significant. And region, gender, and class. So it looks like the region, it probably is a confounder, quite frankly, if you're looking at it that way. So you would look for the ones that not significant, not significant. This one is significant, so region and class. That's kind of how you would do that. I know that's high level, maybe a little bit confusing, but that's how you would do the ANOVAs and ANCOVAs.